Welcome to this video lecture. This is Mark Scythian, FAA licensed aerospace technician, airframe, power plant, and avionics certified. The date today is December 31st, 2017, and the title of this video lecture is How to Factor Quadratic Equations Using the Quadratic Formula. Now, many times people can look at quadratic equations and quickly decipher what the factors are. However, let's say you had a quadratic equation like this. 5x squared plus 14x minus 24 is equal to 0. Now, you might look at the 24 and say you can have factor or multiples of 24, 1, 12, 2, 6, 4, and 8 and 3, and you probably could add them and get a value for 14x, but then again you have a value that's greater than 1, so a lot of times you're going to end up guessing at it, but a more reliable manner to get the factors is to use the quadratic formula, which is x is equal to minus b plus or minus the square root of b squared minus 4ac over 2a. So since this quadratic equation is written in standard form, or ax squared plus bx plus c is equal to 0, you can easily establish that the a is equal to 5, b is equal to positive 14, and c is equal to negative 24. So that being said, we can go ahead and enter in these ABC values into the quadratic formula. So as we compute down, we can use the rules for mathematical operators. 14 squared is 196 minus 4 times 5 times negative 24 over 2 times 5, 10. So 4 times 5 times negative 24, that's negative 480. So 196 minus negative 480 over 10. So since we're subtracting a negative, 196 minus a negative 480, that becomes positive, and then over 10. So 196, let me go to my calculator here, 196 plus 480, that's 676 over 10. Now notice that the square root is positive, and this should be a perfect square. I think it's square root of 676 is 26, but if this had been a positive 24, you would have ended up with a negative square root, and in an algebraic application, technically that would not be factorable because you're going to end up with an imaginary number. And so the correct answer would be no solution or cannot factor. This quadratic equation also can help you verify if the given quadratic equation is unfactorable in algebraic application. So this is another tool to take advantage of to maximize your completion of the problem without wasting too much time. So anyway, we just have a few last steps here to get the x's. So minus 14 plus or minus rewrote it. So that's what you're left with, 10. So the square root of 676 is a perfect square of 26. So x is equal to minus 14 plus or minus 26 over 10. And then this becomes minus 14 plus 26 over 10 and minus 14 minus 26 over 10. So then minus 14 plus 26 is positive 12 divided into 10, which then reduces into 6 over 5. So that's the first x, and then the second x would be minus 14 minus 26, so minus 40 over 10. The second x is equal to minus 4. So if we continue up here, we have the x's for this quadratic equation are equal to x is equal to 6/5, which is 1.2, or 1 1/5 is 1.2, and negative 4. So taking advantage of the principle of 0, we can equal these x's to 0. So x, when we do so, when we equal these x's to 0, the sign will change because x plus some value equals 0 means the sign will change. So x minus 6/5 and x plus 4 are equal to 0. So to get rid of that fraction in the first quantity, we just multiply the first quantity times the denominator to cancel the 5. So that would translate into 5x minus 6. And since there's no fraction, we just repeat that. X plus 4 is equal to 0. And there are your factors without guesswork, lightning quick, using the quadratic formula. So we can test it. We have 5x squared plus 14x minus 24 is equal to 0. We need to factor it. We have the following factors, so we'll expand it to verify if the calculation is correct. So 5x times x, 5x squared, 5x times 4 is positive 20x. Negative 6 times x is negative 6x. And negative 6 times positive 4 is negative 24. So when we simplify it, 5x squared, then we have 20x minus 6x, so we're left with positive 14x. And then all we have left is negative 24 equal to 0. So we verify that. 5x squared plus 14x minus 24 equals 0. So there you go, very quickly. Of course, I was explaining this, so it takes a little time, but once you employ the quadratic formula to find the x's, you can then take advantage of the principle of 0 and reduce it down into the factors relatively quickly without guesswork, and always come up with a correct answer the first time around. You can also use the quadratic formula to verify if you're not getting a negative square root, because if you are, the correct answer would be cannot factor, especially in algebraic applications for which the imaginary numbers are not permissible. Now, of course, you can solve it using complex numbers and imaginary roots, but factoring is a little bit different. So some of the problems you're going to encounter are not factorable, and you might waste a lot of time trying to factor when you can use the quadratic formula to find out if you're getting a negative square root, and if you're not, you can continue on with the calculation and obtain the proper factors. A lot of times you're going to get fractions, but then you can convert them into whole numbers by multiplying a value equal to the denominator to cancel them out. So very quickly, without guesswork, you got the factors for this given quadratic equation. Use the quadratic formula for factoring quadratic equations to your advantage. Thanks for watching, and have a great day.